So let us see a few more questions and answers of Viva on software testing basics. So you may be asked, explain unit testing, integration test, system testing, and acceptance testing, right? So unit testing, first of all, this one is testing performed on a single standalone module or unit of code, right? It is testing performed on a single standalone module or unit of code. And integration test, this testing is performed on a group of modules to ensure the data and control are passed properly between these modules. So when we integrate the modules and then we test, we say that we are doing an integration testing. Then the system testing. System testing is predetermined combination of tests that they are executed successfully when the requirements are met. So testing a predetermined combination of tests that when executed successfully meet the requirement. This is the system test, because you are making a system for certain requirement, and if these requirements are met, that means you are doing a system testing on that. Then acceptance testing. Acceptance testing means testing to ensure that the system meets the needs of the organization and the end user or customer. This is they validate that the right system was built. And what is a test log? IEEE standard 829.1998 defines a test log as a chronological record of relevant details about the execution of test cases. So it is a detailed view of activity and events given in a chronological manner. So this figure shows a test log and is followed by a sample test log. Okay, test log and a sample test log. So test log are chronological order defined records. So these are chronological record and with relevant details of how to execute the test cases. So these are the activities and events. Then you may be asked, can you explain requirement traceability and its importance? So in most organizations, testing only starts after the execution coding phase of the project, right? Most of the organization, small or large, the testing only start after the coding or execution is underway or it has been completed. But if the organization wants to really benefit from testing, the tester should get involved right from the requirement phase. That means if the tester gets involved right from the requirement phase, then requirement traceability is one of the important reports that can detail what kind of test coverage the test cases have. Now the other question may be, what does entry and exit criteria means to a project or means in a project? So entry and exit criteria are a must for success of any project. That means if you do not know where to start and where to finish, then your goals are not clear. So by defining exit and entry criteria, define your boundaries. For instance, or for example, you can define entry criteria that the customer should provide the requirement document or acceptance plan, and if this entry criteria is not met, then you will not start the project. On the other hand, you can also fix exit criteria for your project. Means, let us take an example. One of the common exit area or criteria in project is that the customer has successfully executed the acceptance test plan. So entry criteria may be requirement document or acceptance test plan that is required only on receiving this, the project is going to commence, and the project execution after this project has been executed. The exit criteria may be, say, acceptance test plan by the user. So you may be asked, what is the difference between verification and validation? Actually, we have talked about this earlier also. So verification is review without actually executing the process, while validation is checking the product with actual execution, right? So for instance, the code review and syntax checks is verification. You don't execute it actually, but you check for, if you go into the detail, check for the code, check for the syntaxes, while actually running the product and checking the result. It's actually validation. So let me add few things more here. Verification and validation. Verification is on account of the design document, and validation is on account of your requirement specification. So verification means have you made the product right, and validation means have you made the right product. So what is the difference between latent and masked defects? These are also some questions. So a latent defect is an existing defect that has not yet caused a failure because the set of conditions were not met. This is latent defect, means the defect which is sleeping or which has not been active. And a masked defect is an existing defect that hasn't yet caused a failure just because another defect has prevented that part of the code from being executed. Means if these are code and here is one error, so if the program fails here only and some error is here, so that means this is not going to come, right? This code will not run here. So this particular bug or defect which is not even been executed is termed as a masked defects. Now what is the difference between alpha and beta testing? Alpha and beta testing has different meanings to different people. Alpha testing is acceptance testing done at the development side. Some organizations have different visualization of this alpha testing. So they consider alpha testing as testing which is considered or conducted on early unstable version of the software. On the contrary, beta testing is acceptance testing conducted at the customer level. But please mind that these two tests are actually acceptance testing only. So in short, the difference between this beta and alpha testing is the location where the tests are done. So during development, alpha testing, at the customer end, beta testing. Now other question may be, how does testing affect risk? So a risk is a condition that can result in a loss. So risk can only be controlled in different scenarios but are not eliminated completely. So a defect normally converts to a risk. So verification, a review without execution, validation, testing with execution, and when error comes, then or when the risk comes, you have to see these both parts are equally important. So what is coverage and what are the different types of coverage techniques? This will be asked. Coverage is a measure or measurement used in software testing to describe the degree to which the source code is tested. There are three basic types of coverage techniques as shown here. Coverage technique means statement coverage, decision coverage, and path coverage. Statement, decision, and path coverage. So statement coverage means the coverage ensures that each line source code has been executed and tested, while the decision coverage means this coverage ensures that every decision where true and false is the criteria or the result in this source code have been executed and tested. And path coverage, in this coverage we ensure that every possible route through a given part of code is executed and tested. So we have three tested coverage: statement, decision, and path. So the other question may be, a defect which could have been removed during an initial stage is removed at a later stage. How does this defect cost? If a defect is known at the initial stage, then it should be removed during the stage or phase itself rather than at some later stage. It's a recorded fact that if a defect is delayed for a later phase, it proves more costly. So this is the figure. I'm just going to show you how a defect is costly as the phases moves. So a defect, if identified and removed during the requirement and design phase, is most cost effective, while a defect which is removed during maintenance is 20 times costlier than during the requirement and design phase. Okay, this is how: requirement, minimum cost; design, minimum cost; execution 5 times, testing 8 times, deployment 10 times, and maintenance 20 times. If a defect is identified during requirement and design, you only need to change the documentation. But if identified during the maintenance phase, you not only need to fix the defect, but also change our test plans, do regression testing, change all documents, etc. So this is why a defect should be identified, removed in earlier phases, and the testing department should be involved right from the requirement phase and not after the execution phase. So what kind of input do we need for the end user to begin proper testing? The product has to be used by the user. He is the most important person as he has more interest than anyone else in the project. So user, he has acceptance test plan, scenarios for testing, requirement risk and live data. So from the user, we need the following data. The first thing we need is the acceptance test plan from the end user, and the acceptance test defines the entire test which the product has to pass so that it can go into production. And we also need the requirement document from the customer. In normal scenarios, the customer never writes a formal document until he is really sure of his requirements. But at some point, the customer should sign saying, yes, this is what he wants or I want. So the customer should also define the risky section of the project. For instance, in normal accounting project, if a voucher entry screen does not work, that will stop the accounting functionality completely. But if reports are not delivered, the accounting department can use it for some time. So the customer is the right person to say which section will affect him the most. And with his feedback, the testers can prepare a proper test plan for those areas and test it thoroughly. So the customer should also provide proper data for testing, and feeding proper data during testing is very important. In many scenarios, tester key is wrong data and expected results which are of no interest to the customer. So can you explain the workbench concept? In order to understand testing methodology, we need to understand the workbench concept. The workbench is a way of documenting how a specific activity has to be performed. So workbench is referred to as phases, steps, tasks, as in this figure. Workbench means phases, steps and tasks. So there are 5 tasks for every workbench. Input means every task needs some defined input and entrance criteria. So for every workbench we need defined inputs. Input forms the first steps of the workbench, and execute means this is the main task of the workbench which will transform the input into the expected output. And check means check steps assure that output after execution meets the desired result. So production output, if the check is right, the production output forms the exit criteria of the workbench, and during the check step, if the output is not the desired, then we need to again start from the execution step. So raw product, we execute, we check, if it's okay, production of output, this is the workbench. If it is not okay, we rework it. Now, can you explain the concept of defect cascading? Defect cascading is a defect which is caused by another defect. So one defect triggers the other defect. For instance, the accounting application we have been talking about, there is a defect which leads to negative taxation. So the negative taxation defects affects the ledger, which in turns affect 4 other modules. Right? Defect, negative taxation, ledger, it affects 4 other modules. Now you can be asked, can you explain cohabiting software? You can answer, when we install the application at the end client, it is very possible that on the same PC the other application also exists. So it is also very possible that those applications share common DNS resources etc. with your application. So there is a huge chance in such situation that your changes can affect the cohabiting software. So the best practice is, after you install your application or after any changes, tell other applications owners to run a test cycle on their application. Like your application is there, my application is there, common files, maybe shared files or linked DLS, it may have some cohabiting effect. So what is the difference between pilot and beta testing? The difference between pilot and beta testing is that the pilot testing is nothing but actually using the product which is limited to some users, and in beta testing we do not input real data, but it's installed at the end customer to validate if the product can be used in production. Pilot means really entering the real data, and beta means acceptance plans test. Okay, it is working in this environment. So what are the different strategies for rollout to end users? There are four major way of rolling out any project. Launch strategies: pilot, gradually, and phased and parallel. So the actual production system is installed at a single or limited number of users. Pilot basically means that the product is actually rolled out to limited users for real work. And gradual implementation means in this implementation we ship the entire product to the limited user or all users at the customer end. Here the developers get instant feedback from the recipient, which allow them to make changes before the product is available. So, but the downside is that developers and testers maintain more than one version at a time. And then phased implementation means in this implementation the product is rolled out to all users incrementally. That means each successive rollout has some added functionality. So new functionality comes in, new installation occur, and the customer tests them progressively. The benefit of this kind of rollout is that customer can start using the functionality and provide valuable feedback progressively. So the only issue here is that each rollout and added functionality, the integration becomes more complicated. And as far as parallel implementation is concerned, then in these type of rollouts, the existing application is run side by side with the new application. So if there is any issues with the new application, we again move back to the old application. Now the biggest problem with parallel implementation is we need extra hardware, software and resources. Now what is the difference between system testing and acceptance testing? Acceptance testing checks the system against the requirements, right? It is similar to the system testing in that the whole system is checked, but the important difference is the change of focus. System testing checks the system that was specified has been delivered. Okay, system checks testing is a system. It checks that the system that was specified has been delivered. And acceptance testing checks the system will deliver what is requested. The customer should always do acceptance testing and not the developer. The customer knows what is required from the system to achieve value in the business and is the only person qualified to make the judgment. So this testing is more about ensuring the software is delivered as defined by the customer. It's like getting a green light from the customer, then the software meets expectation and is ready to be used. Now, can you explain regression testing and confirmation testing? Regression testing is used for regression defects. Regression defects are defects which occur when the functionality which was once working normally has stopped working. This is probably because of changes made in the program or the environment. So to uncover such kind of defect, regression testing is conducted. So this is the figure showing the difference between regression and confirmation testing. So confirmation testing, first see this change or fix a defect. So when we change or fix a defect, you do a regression testing to ensure that the defect is not introduced because of this changing and fixing of defect. And the other confirmation testing is ensuring that the defect is fixed. So if you fix a defect in an existing application, we use confirmation testing to test if the defect is removed. It is very possible because of this defect or changes to the application that other sections of the applications are affected. So to ensure